Welcome to Topic Wise. Today we are going to solve one numerical by using the mirror formula and magnification formula. Here is our question. Magnification produced when an object is placed at a distance of 20 centimeters from spherical mirror is plus 1 by 2. Where should the object be placed to reduce the magnification to plus 1 by 3? And first write on the given data. Object distance is equals to 20 centimeters. This negative sign is whatever the spherical mirror, we put the object in front of the mirror, that is left hand side of the mirror. So, we have to write the negative sign, and when object is at 20 centimeters distance, magnification is plus 1 by 2, and we had to find out now object position has changed to certain place, it is kept at certain distance from the mirror. When object is at that certain distance, magnification is plus 1 by 3. So, now we had to find out what is the distance where the magnification is plus 1 by 3. Now, to find out that, we had to find the focal length of the mirror. To find the focal length of the mirror, we need the image distance, because 1 by f is equals to 1 by v plus 1 by u. And to find the image distance, we have two formulae. One is 1 by f is equals to 1 by u plus 1 by v, and another is m is equals to minus v by u. But here we do not know f. So, we are using the m is equals to minus v by u formula, because we know the m and u, and substitute the values. Plus 1 by 2 is equals to minus v by u is equals to 20, minus 20. So, now minus v is equals to minus 20 by 2, that is minus 10. From this, v is equals to 10 centimeters. Now, when object is at 20 centimeters distance from the spherical mirror, the image distance is 10 centimeters, and plus sign shows that the image is at right hand side of the pole, that is one virtual image which is formed inside the mirror. And from this, now find the focal length of that particular mirror. 1 by f is equals to 1 by v plus 1 by u, that is our mirror formula. So, 1 by f is equals to, substitute the values, 1 by v is 1 by 10, 1 by u is minus 1 by 20, LCM is 20, and 2 minus 1, that is 1 by 20, that is 1 by f is equals to. From this, focal length f is equals to 20 centimeters, and focal length f is 20 centimeters, we got positive sign, that shows that this is one convex mirror, because of focal length of convex mirror is always positive. And now we had to find out the position of the object, that what we do not know, when magnification is plus 1 by 3. And to find out the position of the object, we need the position of image and focal length. So, find out the position of image also by using these two quantities, that is m is equals to minus v dash by u dash. U dash is new position of the object, and v dash is the new position of the image when object is at u dash. And when object is at u dash, then what did we given value here, that is m is plus 1 by 3. So, plus 1 by 3 is equals to minus v dash by u dash. So, from this, minus v dash is equals to u dash by 3, and 1 by v dash is equals to minus 3 by u dash. And now use the mirror formula, 1 by f is equals to, now these are the new positions of image and object. And 1 by f focal length remains constant. Focal length of one mirror remains constant whatever the situation, whatever the object distance, whatever the image distance and whatever the medium. In any medium, the focal length of one particular mirror, spherical mirror remains constant. So that here focal length of this given spherical mirror is 20 centimeters. So, 1 by 20 is equals to, we do not know here two quantities. So, that 1 by v dash write in terms of u dash. So, that is 1 by u dash minus 3 by u dash. Instead of 1 by v dash, we are writing minus 3 by u dash, because minus 3 by u dash is equals to 1 by v dash. So, u dash is LCM 1 minus 3, that is 1 by 20 is equals to. Now, 1 by 20 is equals to minus 2 by u dash. From this, minus 1 by u dash is equals to 1 by 40, that is 1 by u dash is equals to minus 1 by 40, that is u dash is equals to minus 40 centimeters. So, when object is at 40 centimeters distance in front of the mirror, then the magnification is plus 1 by 3. And one more we can discuss here. Here this is one convex mirror because f is positive. So, irrespective of position of the object, in case of convex mirror, we always get one image which is less than 1, that is one diminished image, and positive sign of magnification shows us that is one erect image. So, convex mirror always forms one erect and diminished and virtual image. So, our next problem is, a concave mirror forms an inverted image of an object placed at a distance of 12 centimeters from it. If the image is twice as large as the object, where is the image formed? And write down the given data first. U is equals to object distance is equals to 12 centimeters, and we put the object in front of the mirror, so that is negative minus 12, and what else given? Height of the image is twice of the height of object. Let the height of object be HO, and height of image is twice of height of object, size of object. So, that this is 2 HO. And what we have to find? We have to find out the V, where the image has formed. Image distance we can find by using the two formula. One is 1 by f is equals to 1 by v plus 1 by u, and another is m is equals to minus v by u. But when we use the 1 by f is equals to 1 by v plus 1 by u, here v and f both are unknown quantities, and when you use the m is equals to minus v by u, in this formula also m and v are both are unknown quantities, but m we can find by using the height of image and height of object, because m is equals to height of image by height of object. This formula we can use now. So, height of image is 2 HO and HO, they get cancelled. Now, m is equals to 2, but magnification needs one sign. Here what is given? Image is inverted image. When image is inverted image, magnification has negative sign. Now, substitute this m value in this equation, that is minus 2 is equals to minus v by u is equals to 12 centimeters, that is minus 12. So, v is equals to minus 2 into 12, that is minus 24 centimeters. So, that is image distance from the pole is 24 centimeters, and a negative sign shows that image has formed in front of the mirror, that is in opposite direction of the incident ray, so that is negative. Thanks for watching.